Send you upstairs. Good day, Layne. How are you? All right. We are going to get into rational numbers. Who's excited? Micah, you excited? No, Micah's not excited. Well, I'm excited. Layne, are you excited? Get excited. All right. Put the Kindle down, Micah. Put the eyes on the board. Thank you very much. The division of two integers may not always result in integers. For instance, 3 divided by 8, or 3 over 8, and negative 11 divided by 7, or negative 11 sevenths, are fractions. Hence, the integer number system has to be extended to include numbers of the form a over b. We define rational numbers as the following. Rational numbers are numbers that can be expressed in the form a over b, where a and b are integers.
And b does not equal 0.
And b does not equal 0. Thank you. From this definition, we can see that 3 over 1 equals 3. Negative 4 over 1 equals negative 4. 32 ninths and negative 7 eighths are rational numbers. Therefore, rational numbers include all the integers and fractions. So, rational numbers are fractions. All right.
Just twice as hard as he could.
I'm in the middle of a lesson. Stay in your room while I'm doing the lesson. Thanks. Fractions. Sorry about that, Layne. Fractions with different numerators and denominators. Numerator is the top.
I know what it is.
And you know, okay. Viv, be quiet or go in Micah and Eustace's room. And denominators may be equal in value. For example, we can see from the figures below that the fractions 3/4, 6/8, and 12/16 are equal. They are called equivalent fractions. All right, so we see on the board, Micah, how those stay upstairs in the living room.
Oh, I was just going to
Yep.
ask you about that.
So all of these are equal, okay?
Yep, I can say that.
In the fraction 3/4, its numerator and denominator have no common factors except one. This fraction is said to be in its simplest form or in its lowest terms. But you can see how 6/8 and 12/16, they are not in their lowest terms or simplest form. Okay, took the same picture of that. All right. 62. 51. Is it a 5? Sorry, Layne, just making sure I didn't skip over. I think that is a 5. All right, so we're going to look at addition and subtraction of rational numbers. So basically, this is just saying, what are we doing with negative or positive fractions? And how do we manipulate those numbers? Put the Kindle down. All right. The rules of operation on integers also hold for rational numbers. We express rational numbers as equivalent fractions with the same denominator before we add or subtract them. So, for instance, find the value of negative 2 1/5 plus negative 1 1/3, giving your answer in the simplest form. So this is going to be a different way of adding and subtracting fractions because we're going to use what we have learned for the least common multiple. How do we add them? We multiply the reciprocal.
Okay. That's
Okay.
easy.
So
Wait,
the
aren't we gonna do 11/5 over 4/3 times 4/3?
do you want me to stop and explain it before I explain it? Or can I like teach what we're doing first? Can we do that? And then you can ask a question? Because your face like that, I'm sure Layne has a face like that. So let's walk through it before we ask what's going on. You know what I mean? All right, so -2 1/5 plus -1 1/3 equals. So what we've done, -2 1/5, we've made an improper fraction, and it's -11/5. Do you see where are we tracking so far, Micah?
Yes.
Okay. -1 1/3 is the same as -4/3. Get it so far? Okay. So we need to make it such that the denominator is the same. So we're going to convert these two fractions that share the same denominator. And what we did is basically we're saying, okay, well, I know 5 and 3. The least common multiple of those is 15. There's no number before 15 that is a multiple of the two. And because I need this bottom number to be the same for 11/5, I'm going to multiply the top and the bottom by 3. And for -4/3, I'm going to multiply the top and the bottom by 5. So the whole point in doing this is so that we have the same denominator right here, 15. Because when we have the same denominator, we can take the numerator and we're just adding it. So -33 plus -20 equals negative. And all we're doing here is we're putting the negative sign in front because we know it's going to be negative. 33 and 20.
Wait. Isn't it if we divide, then you get a positive number? If you get two of the same stuff and you divide, it's a positive number?
With multiplication and division, you would, if we have this,
Division,
can I finish what I'm, with multiplication and division, if you have the same sign, it's going to be the same. No, if we have the same, if you have the same sign, it's going to be positive. If you have different signs, it's going to be negative.
Right, and we had -2 1/5 and -1 1/3. And we're dividing.
So we're actually adding these numbers together.
I thought we were dividing.
Nope.
Why does
Right
it
up,
say that
right up here, we're dividing. So when we get to this,
But what is it doing? Just let me. Okay, thank you. But up here. Wait, it said dividing. That was a division sign.
no, that's because you were not really paying attention.
It was a division sign, though.
It was not. We're wasting Layne's time now.
Okay, I'm sorry.
Okay, you're fine. That's okay. Everyone makes mistakes. Everyone makes mistakes. It's not a big deal. All right. So then we know, based on looking at the screen, that we have -53 over 15. Okay? So then this is an improper fraction, so we need to change it to the mixed number. So we ask ourselves, how many times does 15 fit into 53? 3 times, because that's 45. Then 53 minus 45 is 8. So we end up with -3 8/15. So let's do this again with these two. We've got -1 1/4 plus negative 2 1/3. Okay, so first we're going to change them into improper fractions. So we would end up with negative 5/4 plus negative, what is that, 7/3. Okay, so we want the denominators to be the same. So we think of what is the least common multiple between 4 and 3. And we know that's going to be 12. So we're going to multiply this by 3 on the top and bottom. And we're going to multiply this by 4 on the top and bottom. Okay? So we end up with negative 15 over 12 plus negative 28 over 12. So then we can write it out like this. Negative 15 plus negative 28 over 12. So then we have what, Micah? 28 and 15 added together are negative 43 over 12. So 3 and 36 is 7. 7, 12. So we end up with negative 3 7/12. All right. If it's not tracking, Layne, it's going to be okay. Let's do the next. Find the value of, 7/8 minus negative 11/4 plus negative 11/3.
So 7/8 plus 11.
Well,
Yes.
so the first thing we're going to do.
Oh, it's 22/8. Yeah, so 22/8. What's 7 plus 22?
So I'm going to follow through this. Can you be quiet while you're doing that in your head, Micah? Okay. So when we look at this guy right here, first we're going to start out thinking through addition and subtraction of positive and negative numbers. We can see that we have a minus a negative, so that turns into a positive. So that's why that subtraction sign turns into an addition sign there. And then we have minus, because we had the negative 1/3, so it's minus 1/3. All right, so now our goal here is we need to consider what's the least common multiple between 8, 4, and 3.
24.
So they've done that work for us. We know that the least common multiple is 24. So how did we get 8 to 24? We multiplied it by 3. How did we get 4 to 24? We multiplied it by 6. How did we get 3 to 24? We multiplied by 8. So that's where those numbers come from. So next we're going to do 7 times 3 is 21 over 24. 11 times 6 is 66 over 24. And 1 times 8 is 8 over 24. Okay? So that's how we get to this line over here. All right, so now we have all these 24s. So with PEMDAS, we're going to do from left to right. So we can do
87 minus 8. Over
66 plus 21 is 87. Okay. 87 over 24 minus 8 over 24. So we end up with 79 over 24, right? So then 24 goes into 3 times. 3 times 24 is 72. So 79 minus the 3 wholes. So it'd be minus 72. We're going to get 7/24. So 3 and the whole 3. So 3 and 7/24. All right, let's work on this one together. Find the value of 1 1/4 minus 8/3 minus a negative 5/9. So what am I going to do before I do anything here, Micah?
36.
I'm going to change this. And we're going to change the 1 1/4. So we end up with 5/4 plus, well, we could just do minus 8/3 plus 5/9. Okay, so next our goal is, what is the least common multiple between 4, 3, and 9? And I believe Micah is correct, and that number is 36.
Actually, no, never mind. No, that's correct.
Yep. So what do we have to do to the 4 to get to 36? Micah.
We multiply by 9.
Okay, so we have to do that to the 5. Right? So 5 times 9 is 45. Minus, what do we have to do to this 3 to get it to a 36? We have to multiply by 12. So we have 36. And then 8 times 12,
I believe it's like
96. Then what do we have to do to the 9?
Multiply by 4.
And then 5 times 4 is 20. All right. Let me tidy this up because it's driving me bonkers. All right. So then we have how do you want to do this, Micah? So we want to work from left to right ideally, but it doesn't necessarily matter.
Now, 45 is half of 90.
Mm-hmm.
So if we just take away the 6 for easiness, just right now, then
51.
So we would get 45 and then add the 6 is 51. So negative 51.
Yep. So we get negative, hang on, 51 over 36.
Plus 20
So
over 36.
here's one way we can adjust this is we can also do 20, 36 minus 51, 36.
I don't want to do that though, so I'm going to add them.
You're going to add the negative. So with that, we find the difference, and then we take the sign from the largest integer. Minus 31. So minus 31 over 36. And that we cannot make a simplest form any more than that. That is the simplest way to go. Let's see what...
Why does it turn white?
I really have no idea. Yeah, I was seeing how long this took.
Oh, it'll take a long time. Wow.
Do you want to... Let's just do it.
All of it?
No, just the C. We'll stop after this one.
Yes!
Layne, if you need to break this up for some reason, that's fine. We're just going to carry on. All right.
Feel free to take any rest breaks you need. Make sure you stay hydrated and make sure your brain's working properly. Don't overwork yourself. And if you're too stressed, get outside, take a walk, get some breather in. Yeah,
Okay.
Just relax.
So now we're going to deal with multiplication and division of rational numbers. So we know that this up here is the proof text for what it says here, which is in mathematics, the multiplicative inverse or reciprocal of a number is that number when multiplied with it yields 100. So what we're saying is if we have these two rational numbers, then multiplying them equals this, and dividing them is when we are multiplying by the reciprocal. So notice C over D changed to D over C. So A times D equals B times C, provided C does not equal 0. All right, so remember, Dallas, can you stop that, please? The reciprocal of 5 is 1/5, and 5 times 1/5 is 1. Reciprocal of 3/4 is 4/3. When we multiply, we get 1. And the same, it goes on. We've done this before, Layne. I'm sure that you remember. The thing that we're doing right now is we're adding negatives into the mix. So -8 and -1/8 equals 1.
Why do you even need to make it negative? Because it's going to equal the same answer as 8 times.
Well, but if you start with, if you have, let's see, 3 divided by -1/8, then that's the same as 3 times -8. You need this negative here because when you do 3 times 8, it has to be a negative. Does that make sense?
Yes.
Yes. Okay. So 1 and -1 are their own reciprocals, respectively, as 1 times 1 equals 1 and -1 times -1 equals 1. 0 has no reciprocal, as the product of 0 and any number is always 0 and never 1. Thus, when we divide a number x by a number y, we can multiply x by the multiplicative inverse or reciprocal of the number y. That is 1 over y. For example, 6 divided by 2 equals 6 times 1/2, which is 3. Multiplication and division of rational numbers are similar to those of integers. Suppose a and b are integers. The following holds true. A divided by b equals a times 1 over b equals a over b. Yes.
I just found out that if you put a negative person with a positive person, then they end up being negative. But if you put two negative people together, they understand each other and are more likely to become positive.
No, I think they would actually just doomsdify everything.
What's doomsday?
Yeah, look at the negative of every single thing. They may understand each other, but they could dive deeper. Anyway, we digress. Let's get back to the math. And again, try not to waste Layne's time. Although Layne would probably enjoy this conversation.
Right?
Right, Layne, right. All right, so no.
That's McDonald's coffee. Never mind.
Yeah, it's unsweet. It's not special. There's not, I mean, just.
I already had coffee this
Okay,
morning, but
I'm
it's
going to
still
continue the
warm.
lesson. Can you stop? You spilled half of the
I
coffee.
know, but I took the green machine and did this.
That doesn't work properly. It sucks it up.
I know.
Oh, gosh. Oh, my God. All right, so anyway, -a divided by -b equals -a over -b, which equals a over b. -a divided by b equals -a over b. So notice we keep that negative. A divided by -b is a over -b. So -a over b equals a over -b. Do we see this? It's just it's the negative sign applies to the whole integer. Note, -8 divided by 2 is -8/2, which is -4/1, which is -4. 8 divided by -2, so this is fleshing this out. 8 over -2 equals 4 over -1, which equals -4. So see how these are the same, just like those are the same. So since -4 equals -4 over 1, -4 over 1 equals 4 over -1, which equals -4 over 1. It's so many words. And this is important later as we get more complicated with algebra, pre-algebra, all the funsies. Okay, so let's evaluate some expressions. Okay. It was blissful. All right, so let's evaluate this. Micah Daniel, -9 over -9.
What?
Equals 1. Any number over itself equals 1, right? So, and this is our proof equation, right? If we have two negatives over, we end up with a positive. Because remember, with a multiplication and division, if we have the same sign.
What is wrong with B? There is -9
Hang on.
over 1/9.
Can you just stop for a minute? So if we have the same sign and we're multiplying and dividing, we get positive, right? If we have different signs, we get negative. So let's flesh this out, because Micah, you're right. This looks bananas.
But wait, wouldn't you? Since
So,
it's division, since
yes,
division,
yes.
so then it's just -9 over 9, which is.
Hang on. Just wait. So we end up with -9 divided by 1/9. So there's -9 divided by 1/9. So then we end up with -9 times, notice we changed, so we're doing the reciprocal.
Oh, yeah.
-9 times 9 equals -81. Do you see how this mind bend, you have to flesh it out step by step. Otherwise, your mind explodes. Just wait until we add variables into these things. And then the step-by-step nature is very importante. All right, so let's look at this guy.
We didn't do that. Let me do the other ones a bit.
I'm doing what I'm doing, and you just have to go along. 1/9 divided by -9. So here we have 1/9 divided by -9. All right, so we're going to change that division into a multiplication. So we have 1/9 times the reciprocal of -9. So that's what number times it would change it to, would be 1. So that's -1/9.
-81. 1/80.
So,
-1.
yes. So when we do this, we multiply straight across. And because we have different signs, we're going to end up with a negative number. And you are correct. -181. All right. Do you see how this is kind of fun?
Okay, can we do that? Try it.
Yeah, I
Can
see.
we
Do you see how you're like nerding out right now?
I am nerding
It's
out.
so fun. Thank you for being nerdy. I just love you. I just love you. I love you too, Layne. I miss you. I love your hair.
The answer is -1.
Okay, yes. So any number over itself is 1, but we have to deal with this negative sign. So it's -1. All right. Read me off this one, senor.
So that would be, since it's division.
Do it step by step. So
Okay,
what would be the next step?
-1/4 divided by -8. By 8, by +8. We multiply by the reciprocal, which is -1/4 times 1/8. And then we multiply across. 1 times 1 equals -1. And then 4 times 8 equals, let me think, 32. Bam.
All right. Now this, look at that funsy. Funsy little fun. Funsy little fun.
Negatives, which means it's a positive.
That's insight, but let's get there. Breadcrumb at a
Okay,
time,
so
please.
first
Thank
we
you.
did, it's -7 divided by -1/2, which means we multiply by the reciprocal, which means it's -7 times 2, -2.
Mm-hmm.
Which means, since we have 2 negatives and we multiply across.
And remember, here's our little meat and potato box. Same sign means our answer is going to be positive.
So it's 14.
So we end up with 14. Isn't that beautiful? All right. So now we're complicating things a little bit, because now we are evaluating this and we have a mixed number. Okay. So look at the page. Micah, you held that. You ruin everything. I don't like it because it's not straight across. It makes me uncomfortable. All right. Stop it. I hate you. I don't hate you.
You liked me nerding out.
I do. I like you nerding out straight, not diagonal. Okay? We have -2 and 2/5, and that turns into -12/5. And then we have 3/4 and 3/4. So then our dilemma, what are we doing? Oh, yep. Then we're multiplying straight across. But look at this guy. We can simplify this into what? 1, 3. So then we end up 3 times 3 is 9/5. Notice they're thinking, and the negative still stays. So then when we turn this into a mixed number, we get -1 and 4/5. All right. So let's do this guy. Micah, tell me which. That is the entire problem.
-6 and 2/3 times 2/5, which means we're going to be doing, let me figure it out, 20/3 times 2/5, and we can simplify.
Yeah.
20 and 5, 20 3 and 4, 5 turns to 1, 4 times 2 is 8, 3 times 1 is 3, 8/3, which is.
Oh, wait. Look,
Negative,
we have to make sure we do.
which is -2 and 2/3.
Bingo. Hang on, Viv. I'm doing a math lesson.
I'm matching your energy today.
I love that you're matching my energy. Watcha. See how much when
I
you.
just farted.
Yeah, I heard that. I'm ignoring it.
I bet you're gonna be stanky over there.
All right. Oh, this is the same page. Duh. We already did that, Layne. Let's see. Okay, we got one more little guy. Then we might do a couple of the baby practices. Okay, so now here's where, look at these parentheses and brackets. Look at this fun. Look at this fun. That is fun.
You have to do the -1
Hey, we got to do a lot of stuff. Okay, so first, let's track where they're tracking. So we have negative 2/3 and negative 2/3. Now, PEMDAS, we're always going to do the innermost brackets here. And what does that mean? That means we need to do a negative and negative, so it's going to be a positive. So then within those brackets, we end up with the 1/2 plus now 1/3, and that's here. All right, so now again, PEMDAS, parentheses first. So we are going to do this addition before we do anything else. So what is the, okay, I see what we did there. Okay, how do we get these to be the same? Well, we end up, 6 is the least common multiple. So what do we do to 2 to get to 6? We multiply by 3. So we do 1 times 3 over 6 plus 1 times 2, because the 3 we multiply by 2, 1 times 2 over 6. So then we can just get rid of this guy here and add that. So what is this getting? I mean, why did we put the 1s? I don't even know. So we end up with basically 3 plus 2 over 6.
5, 6.
Hang on, I got something in my eye.
12. Or
All right, so we end up with negative 2/3 divided by 5/6. All right, so what are we going to do to change this division into multiplication? We're going to multiply by the reciprocal of 5/6. So that would be 6/5. So negative 2/3 times 6/5. We know that these are mixed signs, so it's going to be negative. So we're going to end up with, look, we can simplify. We got a 3 and a 6, so we can divide both by 3. And then we would get 4/5. And that negative tracks. And look, negative 4/5. Bingo. All right, so let's do this example now. So Layne, I want you to pause the video and try to figure it out for yourself. All right, welcome back. Hopefully you tried, and let's see if what you did matches what Micah and I are going to do. All right, so our first step, because we're going to be dealing with the innermost parentheses, our first step is going to be adding these together, okay? So we need for the denominator to match. So what are we going to do, Micah? The least common multiple between 3 and 5 is 15, right? So negative, and so we're going to do 15 on the bottom of both and plus negative. All right, so what do we do to 5 to get to 15? We did 3. What did we do to 3 to get to 15? We multiply by 5. So then we have 3/4 negative. Make sure you keep track of your signs. Otherwise, you're going to get things wrong. Negative 3/4 divided by what, Micah?
negative 3/4 divided by.
Now we're doing addition here.
8/15.
Negative 8/15. So what do we do next, Micah Daniel? Negative 3/4 times negative 15/8.
And then we can, oh wait, no, we can't do the cross the other thing. 3 times 15 equals
45. And so we know a negative times a negative, we're going to end up with a positive number. So 45 over 32, right? How many 32s fit in that 45 to get it into 1? So we have 1, and 45 minus 32 is 13. 1 and 13 30 seconds.
30 seconds.
Layne, did we do it right? Is this what you got? I hope you did. I know that you can do this. If any of this is overwhelming, please try to watch the video again. Ignore Micah's sounds because they're annoying. Let's do a couple of these just for funsies. All right. Dallas, how do we get 48/84 to something over 7? What did we do to the 84 to get to 7?
I know this one. You know.
Well, we need to multiply 7 to get to 84, and that's what.
Well, you yes. So if I half that 84, it would be 42. So how many 7s fit into a 42?
Me. Right here.
6. And so we have two of those, right? So we have 12. So 84 was divided by 12 to get to 7. So we're going to do 48 divided by 12, which is
4.
4. Perfect. All right. So, Micah, do C.
Do see. So, do you multiply 4 by -16? Yeah. So we multiply by -16. 5 times 15. 75. 16 would be 80. So -8. So -64 over 8.
Over 80.
-80. Yeah.
And that's a really good observation because in order for this 4/5 to be positive, we have to have negative on the top, which was what they left us with, as well as the bottom. All right, let's look at this guy. Micah?
Multiply by -9.
Multiply by -9. So, or you're dividing by -9, right? So 72 divided by 9 is what, my dear?
8.
8. So note, because we had negative and negative, we need this to be positive. All right. I believe this is 98.
Yeah, that's what it is.
Walk me through your thinking on this one. Because this is just a little tricky. You have to keep track of what you're doing with the negatives and the positives.
So,
Mom, are you almost done?
I need to know the multiples of 14. Can I see a calculator?
Hey! There's one in your sister's room.
Calculator. So we're just gonna find out
Multiples of 13?
14.
Of 14. So we could do 14,
Give me the
28,
calculator.
42.
28 plus 14 equals 42. Plus 14 equals 56. Plus 14 equals 60. Plus 14 equals 74. Plus 14 equals 88. Oh, you have it. Whoop. Okay, so how did you get 98?
So do 98 divided by 14.
98 divided by 14 equals. That's not right. 98 divided by 14 equals. Count. Okay, 14 times 7 equals 98.
Okay. So what did we do to 98 to get to negative 14?
We
Divided by what?
Negative 7.
Okay. So whatever we do to the top, we're going to do to the bottom. So
What
then
is
negative 21 divided by negative
3?
7
3.
is going to be 3.
Positive 3. Make sure you keep track of that one.
Yeah, it's going to be a positive 3. And that ultimately, if I was saying, hey, let's make this into a proper fraction, which would be a mixed number in this case, it would be what? 4 negative 4 2/3. All right.
Enough yet, Layne? Because we're still going.
Okay, the reciprocal of these, 4 ninths, 9 fourths, negative 1/20th,
Oh, that's so...
negative 13 sevenths.
No,
and-
that's positive 13 over negative 7.
Yeah, but the whole you can change the whole thing into a negative.
Okay.
Okay, and then we would have 8/5, so 5/8 there.
5, 8.
All right, so this part is the fun part.
Oh, no. No.
These are too easy. Let's skip those.
What?
And let's jump into D. That's fine. It's not that hard. So we have negative 1 minus negative 5/6 plus 6/5. So I see a negative and a negative. And when we have a subtraction and negative, that means we're going to be adding. Okay, so then we have negative 1 plus 5/6 minus 6/5. Or I could say plus negative 6/5. So I could say negative 1 plus negative 6/5 would be negative 1 6/5 plus 5/6. Okay. So
30.
we would have negative 1 36/30ths, right?
Yeah.
Plus
30.
30/30ths. Okay. So we're finding the difference and then we're keeping the
No,
sign.
it'd be 25 30ths.
Yeah, that's right. That's right. 25. Okay, let me just erase that.
Erase it, yeah.
I'm getting there. Just
Your brain needs to chug along.
all right. So we're finding the difference and then giving it the negative because that's the larger number. All right, so the difference between the two is 1 and, what is that? Is it 11/30ths?
That's 11. What? Which one?
The difference between these two. 36 minus 25
That would be
is 11.
30th.
Yeah, so, and then we're doing a negative. So negative 11/30ths would be our answer. Oh, that was fun. That was fun. All right, let's do F. Oh, look at here, Micah.
Yay.
There's an exponent. Okay. So what are we doing?
So it says exponents first.
Mm-hmm.
So what we're gonna do is we're gonna multiply negative 7/11 times negative 7/11, which we will 11 times 11. Let's figure out what that is first. Okay, we're gonna use our calculator.
Mommy.
It's 121.
Okay, so that's
49 over 121.
yep, 49 over 121.
Now that's a negative, by the way.
No,
No, it's a positive.
it's a
Yeah,
positive
it's
because we're
negative,
multiplying
negative.
two negative numbers.
And then we add negative 7/11. So that becomes
Well, we need the 11ths to be equal again. So it's going to be, look at this. You can't subtract without the denominator being the same.
Okay.
Yeah, you can't.
You can't.
Can't you just subtract the denominators from each other?
No. Nope. So, huh?
Never mind. Nothing.
So we're going to multiply 11 times, what do we do? 11 times itself, right? So we would get 121, and then 7 times 11 is 77, right? So then we have 49, 121 minus 77 over 121. So we know our answer is going to be negative, right? Because so 77 minus 49, the difference, and then the sign of the larger number. 77 minus 49, 28. So we end up with negative 28 over 121. I feel like 121 is divisible by 3. Is it? No.
Yeah. What?
121 divided by 3 equals 40.3.
No.
You would have a remainder of 1. If you, well,
Okay. Yeah, so it's not. All right. So we did these and these. Micah, stop. All right. So let's do E here. So it's 24 over 25 times 45 over 16. We have a negative, so we know our answer right away is going to be negative. That's right. So let's divide these by 5. We end up with 5,
and 7.
9.
And 9, yeah.
Oh, look at these. We can divide these by 8. And we get 2 and 3, right? 3 times 9 is how much?
3 times 9 is 20.
And 2 times 5 is 10. So then we end up with negative 2 and 7 tenths. Yeah. All right, let's do this one. Negative 1 and 3 fifths divided by negative 1 and 1/3.
Way I'm a positive.
So let's first put them into, we are going to have positive because it's 2 negatives. Let's first put them into as an improper fraction. Okay, so we would have negative 8 fifths divided by negative 4 thirds. Least common multiple of 5 and 3 is
15.
Oh, wait. I'm not doing that yet, aren't I?
Yeah.
What's the next step?
4 times 8. 8
Nope.
times
Nope.
4. Oh, multiply by the reciprocals.
Yes.
Flip 'em.
Negative 8 over 5 times, I could do negative 3 over 4. And then look over here. We have 1 and 2. So negative 2 times negative 3 equals 6 over 5, which equals 1 and 1/5. All right, let's do this last guy.
3 plus 2 and 1/2 plus
All right,
negative 1 and 1.
3
Nope, that's divided.
plus 2 and 1/2 divided by
That's
negative 1 and 1/4. No, it was division. All right, so the first thing that I would do is let's change this into the improper fractions.
that would be
3 plus,
just
Oh, wait, you can't do that. Okay. Yeah, so That's gonna equal 4 halves.
5 halves.
5 halves. I know the 2 is 4 halves.
Divided by
Negative 1 1/4, which is 5/4. It's
negative
5/4.
5/4. All right, so our next step is to
Multiply by the reciprocal. And then you cross out the 4 and the 2, and you get 1 and the 2. And then you cross out the 5 and the 5, and then you get 1 and 1.
Now, why am I not doing this part first?
Because PEMDAS.
PEMDAS, parentheses, exponents, multiplication, division, then addition and subtraction. So we have to deal with this side first. Okay? So Mike is right. 5, 5, that's 1 and 1. And then we end up with 1 and 2. Don't forget our negative hiding right here.
So it's
negative 2
plus 3, which equals
which equals 1. So 3 plus negative 2 equals 1.
And if I didn't have a brain, mine would still be bigger than yours.
Micah, that's very rude.
On
Very rude.
6. How many times?
Ooh, let's see if there's any fun things here we could do.
Can we
If
do
fraction
that?
is equal.
Ooh,
Ooh, can we do the math book 7?
Math hour.
okay.
No.
So let's see.
Bye-bye. Shut your door. We don't care.
All right, if a fraction
Hold on.
is equal to 3/5 and the sum of its numerator and denominator is 16. Gosh. What is the fraction?
Well,
Okay, so let's look for... Shut your door, Clinton. So let's see if we can figure this out. I'm not sure that we will, but...
If fraction is equal to 3/5 and the sum of the numerator and denominator is 16, what is the fraction?
well, then it would be 8. Then, like, all of it.
It has to be equal
Oh.
to 3/5.
All right, so... And the sum of the numerator... Okay, so we could do 6/10.
Would that equal 3?
Well, that's the problem solved.
That's the problem solved. There we go. The sum of the numerator and denominator, that's numerator, denominator, is
I thought it was
16.
multiplication for a second. I was like,
I know, that was...
That's easy. If it was just that, you could just split the 16.
that's like the easiest problem we've had all day.
I know.
And like the math at work stuff is like supposed to be hard.
All right, let's
Come
look
on,
at this.
guys.
Consider the rational numbers 3/4 and 9/11. Which is larger?
Ooh.
Just that. That would be.
Well, let's do least common multiple, which would be 44. 4 times 11, so that's
3/5 is
33 over 44.
3/4.
And this would be times 4, 36. So 9/11 is larger.
Hey,
Then-
Layne, that's your birthday.
Yes, that's true.
9/11.
Find two rational numbers between them. I mean, that's 34 44ths and 35 44ths.
Man, that's so hard. It is unbelievably hard, Layne, is that not?
Are you able to suggest the number of rational numbers between 3/4 and 9/11? Give your answer.
No, that one is slightly not. Isn't it?
I mean, there would be,
Endless.
well, not endless, because
Actually, there is.
would it be endless? Because you'd have to have whole integers for the rational numbers on the top and the bottom.
You could do whatchamacallit. You know how you can go like with decimals, you can go like all the way back.
But we're not doing decimals.
No, wait.
We're doing fractions.
So I'd say it's like
Because, like, what can you put, what can go between these two that it's whole? Nothing.
Okay, 2.
What can go between these two that's whole? Nothing.
So it's 2.
So it's got to
I'm
be
like
2.
way off.
That's okay. I think, I mean, it's something where like these kind of problems always make me second guess myself. Like, I don't know. Am I right?
I was thinking basketball. So
All right,
like,
Layne, that's all we have for you. I love you. I hope you're